So today in class, we practiced solving quadratic equations that were not factorable. We used the quadratic formula, which we saw was a review from Algebra 1. So right now you're going to watch a video on another method for solving quadratic equations. But before we get started, there is a do now right here. So why don't you give them all a shot? You are factoring completely. All will ultimately be the AM method. However, make sure that you look for a GCF first. So for A, we have our AM method. What adds to positive 16 multiplies to positive 64. X squared becomes X and X. And then adding and multiplying, we should be using positive 8 and positive 8. Keep in mind, since these two parentheses are the same, another option for writing this would be x plus 8 squared. For B, same thing, AM method, adding to a negative 12, multiplying to positive 36. You should get x minus 6, which again, another method for writing that would be x minus 6 squared. For C, this one does have a GCF of 2 that we can take out. I would recommend taking it out first because now we see that we do not have a leading coefficient anymore, so now we can go ahead and do our regular AM method. We would get x plus 3, and again, another option for writing that would be an x plus 3 squared. Now for all of these, notice that each one was able to get written as a parenthesis being squared. For every single factoring, you had the same binomial, the same factor twice. We call each of these perfect square trinomials when this happens. This is going to be a big goal of what we are doing, is to try and come up with these perfect square trinomials. So we practiced today the quadratic formula. Today, we're going to be solving by completing the square, which again, just like today, the quadratic formula, it was review. Completing the square is a review of Algebra 1, and you used it a bit in geometry. So this whole thing should be a review for you. If you forget, these are the steps that I am going to be following for completing the square. So you want to make sure that you do know them. You do need to have them memorized because you can solve any quadratic equation by completing the square. However, there are times that the directions specifically tell you that you must solve by completing the square. So your only option is to use this method in that case. Otherwise, the best that you can do is get half credit on these questions on the regions, which that's only if you do it perfectly with the other method that you choose. So it would be preferable if you did this with completing the square. So we're going to try number 1 right now. I'm going to follow these steps again up here. So step 1 must be 1. Oh, that should say the leading coefficient must be 1. So make sure that it does say that in there. The leading coefficient must be 1. In this case, it is. So in front of the x squared, that is technically a 1 there. So we're good with step 1. So now we're going to go to step 2. Move the constant term to the other side of the equal sign. The constant term, remember, is the number without a variable, in this case, the 23. We want to move it over to the other side. So in order to do that, we are going to subtract it in this case. So we get x squared minus 12x equals negative 23. So that is done with step 2. Step 3 says to prepare to add the needed value to create a perfect square trinomial. Now, our goal is to get this left side to be one of those perfect square trinomials you saw in the do now. In order to do that, you are going to be adding a number in here because in order to be a trinomial, we do have to have 3 terms. But mathematically, if you're going to add something to the left side of an equation, we are also going to add it to the right side of the equation. So now, step 4, to find the needed value, take half of, that should say b, square it, and then add it to both sides. The b is the number that is attached to the x. In this case, that would be the -12. So step 4 right now, what you are doing is you are taking half of the b value and then squaring it. So in this case, the b is -12. Taking half of that, you now have -6, and then squaring it, it turns it to a +36. Because of the squaring in this step, all of these numbers should always be positive. So now that we have it, we are going to add it to both sides. All right, done with step 4. Done with step 4. From here now, you are going to factor the trinomial. This left side here, again, we just created a perfect square trinomial, AM method. This is the only time you are allowed to factor when you are not equal to 0. So AM method, what adds to -12 and multiplies to +36. So -6 and -6. On the right side, we can combine like terms here, so you should get a +13. Now, because this is a perfect square trinomial, you can write this as x minus 6 squared equals 13. It is called completing the square, so we just made that a square. And now from here, you are left solving. The ultimate goal is to solve, so we do have to get x by itself. So right now we have this squared that we need to get rid of, so the opposite of something being squared. We take the square root of both sides. The squared and square root on the left will cancel with the x minus 6 popping out. On the right, we have the square root of 13, which unfortunately cannot be simplified, so it is still just the square root of 13. But the big thing that you will have to remember, quadratic formula had it built in already, but for completing the square, you have to do it yourself. We are going to put a plus minus in front of the square root. All right, we do have one more step to get x by itself. We are going to add the 6 to both sides. Now, this last number that you are moving will always go in front of the plus minus. 6 and radical 13 are not like terms, so there is no way that they are combining as one single term, so they do stay separate. And this is your final answer. X equals 6 plus minus the square root of 13. All right, on the next page, why don't you try number 2 on your own? Press pause, and when you're ready, press play again. All right, so step 1, if there was a leading coefficient, divide it out. In this case, we're good to go. So step 2, we're going to add the constant to the other side. So we have x squared plus 4x equals 16 now. From here, we're going to prepare to add something to both sides. Whatever we add will make this left side into our perfect square trinomial. So to find that number, this is where you are going to take half of the b and square it. The b is the number attached to the x, so in this case, 4 divided by 2 squared. Well, 4 divided by 2 is 2. 2 squared is 4, so we are going to add 4 to both sides. So the left side now can factor as x plus 2, x plus 2, which, rewriting it, this is called completing the square, is x plus 2 squared. The right side, 16 plus 4, is 20. From here, square root both sides. We're square rooting the left so we can cancel the squared, but then if we're going to square root the left, we have to square root the right. So on the left, the x plus 2 comes out. On the right, keep in mind your directions do say simplest radical form. Radical 20 is 4 times 4. 4 is a perfect square, so it becomes 2 radical 5. And we're not going to forget the plus minus in front of that. From here, last step, subtract the 2 over. Those will cancel on the left. You get x equals, and again, this negative 2 does not have a radical, so it cannot combine. So it is going to move to the front of the plus minus, and you should get negative 2 plus minus 2 radical 5 as your final answer. All right, last one, number 3. Number 4 you're going to do on your own tonight. So number 3, notice this one. My x squared is not by itself this time. It does have something else with it. So we do need that x squared to have a positive 1 as a leading coefficient. Otherwise, you cannot follow these same steps for completing the square. So since x squared is being divided by 4, to get rid of it, you are going to multiply by 4. They will cancel, and you're left with x squared. However, if I'm going to be multiplying the left side by 4, I also have to multiply the right side by 4, and you are multiplying the entire x minus 2 by 4. So distributing the 4, that gets me a 4x minus 8. Now, if you look back at the last couple that we did, the x's had been on the same side of the equation in order to make the perfect square trinomial. So you are going to have to do that again now. So to do that, we subtract the 4x over. You get x squared minus 4x equals negative 8. Now, you could have moved the negative 8, also made it a positive 8. However, one of the steps says that we have to move the constant to the other side. You do want to get the x's by themselves. So if I leave the negative 8 where it is, it saves me that step because now it's already ready to go to find that constant that I'm going to add. So I can create my perfect square trinomial. So again, half of the b squared will get that number for us. So the b in this case is negative 4. Taking half of that, you get negative 2 squared. And squaring it, remember we do get a positive 4 after squaring. So adding 4 to both sides, we can now factor the trinomial x minus 2, x minus 2, which is x minus 2 squared. On the right, negative 8 plus 4 is negative 4. So right now we have x minus 2 squared equals negative 4. Square root both sides so we can cancel the squared. The x minus 2 pops out. Square root of negative 4, well, the negative comes out as an I, so this is I radical 4, And then 4 is a perfect square, so we do get a 2i. And just like with the radicals, we want to include that plus minus in front. Last step, add the 2 over. Just like with the radicals, though, that 2 that's moving right now, it is not like terms with the 2i. So it will just move to the front of the plus minus. So your final answer, 2 plus minus 2i. So like I said before, right now you are going to finish number 4 for tomorrow. We will go over it and then we can practice both methods for the period. So good luck. If you have any questions, let me know tomorrow and I'll see you then.